Now this module is going to be centered around an extremely important concept, and that concept is data modeling and constraints. Now data modeling is an extremely integral part of modern application development. So this module will introduce you to a few conceptual points which would be very relevant in the space of data, its various modeling, and the constraints that one would face. The high-level objectives of this module is to cover basic data modeling concepts, as we said, but what we'll try and do is actually get the points across through examples. In particular, we'll be focusing on a blog site and then also an e-commerce site. So when you're looking at this space of data modeling, then there are a few concepts that you need to be familiar with. The kind of concepts are primary keys, foreign keys, constraints, normalization, nullable columns, schema migrations, and so forth. So one of the things to just note, which I just want to sort of highlight before we get into this module, is that some of these concepts may be slightly conceptually tricky to absorb initially. But don't worry about that. The whole objective of this particular module is to expose you to some of these concepts, so you should know that these concepts are relevant. And certainly when you do the practicals, then a lot of these concepts will become much clearer to you. Now, over and above the concepts, one also needs to pay particular attention to modeling data across real-world types. So you should also be and will eventually become familiar with relationships within your data, enum types, storing files, and transactional types. So our task is going to be the following. We're going to start modeling a blog apps database. Now, a typical blog usually has a combination of text, digital images, links to other blogs, links to other web pages, and so on and so forth. So what will a very simple blog app have? It would have users, it would have articles, it would have categories and tags, and it would have comments. Okay, so now let's look at each of these individually. Now users can log in and actually write articles. Now each article will have only one author. Each article will have one category, but perhaps many tags. And each article can have many comments posted by users of the application. Now, one of the things to be careful of, or one of the things to really understand at this point of time, is categories and tags. So let's look at categories first. Now, a category is essentially there to help identify what your blog is really all about. Okay, so think of these as sort of general topics, or you can even think of it as a sort of table of contents for your site, so to speak. The essential idea is it is there to assist readers finding the right type of content on your site. Okay. When you're looking at tags, now tags are meant to describe very specific details of your posts. So one way of thinking about tags is that think of them as your site's index words. So they are essentially the microdata that you can use to micro categorize your content. Right? So let's take an example. So let's assume you have a personal blog, and in your personal blog, you really want to write about your life. So your categories may be something like food, or music, or travel, or the books that you read, and so on and so forth. So now when you go out and eat something, and you want to write a post about something that you ate, it will naturally fit into the food category. And in that food category, you can add tags like a pasta or a pizza or Italian food or whatever else that you actually ate under the food category. So tags would be things like pasta and pizza, and the category would be food. So remember that users can actually log in and write articles. So a very simple table to store user information would be the following. You have the username, which is text, the age of the user in integer, email, which is in text, and description, which is text. Now when we get to articles, here's one option for writing the information. That is, you have the title, the content, and the author. Now we can certainly do this, but this may not be such a very good idea because the author name can be different from the user's name on the user table. Okay, let me repeat that again. The author's name can be different from the user's name on the user table. Now this may become painful for the following reason. That suppose the user's name updates, then we wish to update all rows that have articles that are authored by the author whose name is actually changing. Okay? So now let's consider another option. Another option is you have title, content, and a user ID. Now this is better, but this allows for lots of other problems to creep in, where if the user ID doesn't actually exist. So what if the user is actually deleted? Do the articles stay, or should they also be deleted because the author is also deleted? Okay? So now let's look at option 3, where we have title, content, user ID, and we are now introducing something known as a foreign key. Now a foreign key is essentially a field in one table that will uniquely identify a row of another table. Okay? So it's a field in one table that uniquely identifies a row of another table. So let's put it in sort of simpler words. So the foreign key is defined in a second table, but it refers to the primary key in the first table. Okay? So now let's get on to categories. So remember, if you were talking about a personal blog where you were writing about your life, then sample categories were things like music, food, travel, books, and so on and so forth. Now we have a category field, and this can be a text field. So here's a question. So how can we guarantee that each article's category is from a common set of categories? So we don't want any new categories to be randomly created or specified along with an article. Okay? So now if you have a foreign key to category.name, which translates to category name text, so now essentially what happens is that random categories actually cannot be used or created in some random manner. And now let's get on to tags. Right? So remember again that in the category of food, if you went and ate something, you can add tags like pasta or pizza. So we can add tag columns in this manner, tag 1, tag 2, tag 3, tag 4, so on and so forth. But in the manner that has been described out here, it is limited and it is not very elegant. So what we can do is we can add a tags column which has comma separated tags, right? So for example, you have web, apps, databases, so on and so forth. So the question is, how can we actually search for tags efficiently? Now the problem is that we will have to read each row, then convert the tags from the comma separated values to tags, and then match against each tag. So you see that you'll end up with a specific problem in your database, and that is that your database will not be able to index this specifically. So you can do the following. You have article ID integer, which is article underscore tag, article underscore ID, which is integer, and tag, And essentially what this does is we can actually find all articles for a particular tag very easily. Okay, so let me repeat that again. With this, we will be able to find all articles for a particular tag very easily, but you end up with another problem, and that is, what if we want to tag the tag to be from a subset of specific tags? Okay, so the question we want really addressed is, what if we want the tag to be from a subset of specific tags? And in which case we do something very similar that we did to the category table, right? So remember what we had done to the category table. That is essentially what you do here as well, and hence we will be able to look at the tag from a subset of specific tags. So now that we've gone through this example, there are numerous patterns that seem to be coming up. The very first one is, do not keep redundant data. Only keep a single copy of the truth. Now this can't be emphasized enough, right? And to emphasize it again, I'll repeat myself, do not keep redundant data. So user underscore ID instead of using author underscore name as a column in the article table. The second main point was that to constrain values, use foreign keys. Now let us recall that a foreign key is a field in one table that uniquely identifies a row of another table. So note that foreign keys are not pointers, they are constraints between columns of tables. The third point is that a many-to-one relationship can be modeled by having a foreign key column in the table. So for example, many articles can belong to one owner. And finally, a many-to-many relationship can be easily modeled by having a separate table between two tables that has foreign keys to both the tables. So for example, an article has many tags. Each tag can be used by many articles. An article underscore tag table has a foreign key to article table via an ID, and the tag table via the tag's name. So these are four key patterns that will come up again and again and again, and we should be aware of them. And now what happens if we want to actually store files? Now it's quite common that every user will have a profile picture. So what column should we use for storing files? Now note that most databases have a blob type or a text type that can store a lot of bytes. So here you'll have profile underscore pic, which is binary / text. But this is actually a bad idea. Now think about it. Why might it be a bad idea? The reason is that storing the entire file in the database will actually end up causing serious performance issues, as the database would load the file as well, which can be a lot of data, every time we need to read or update the other fields of the row in the table. Okay, so if you have an entire profile pic there, every time there is a read or an update, all of this data will be updated or moved. So instead what we can do is we can store the file on the file system and just store the link of the file on the file system in the database. Okay, so essentially you have profile underscore pic and then you have link to the file. But now the thing is that the developer will have to make sure that the constraint between the file link and the actual file is maintained, as the database actually cannot help. So if a file is deleted or its link is updated, this unfortunately cannot be handled by the database. But it's worthy to mention that the performance improvements are worth the trouble, right? Because essentially if you don't do it this way, you will actually be loading the database every single time there's a read or an update. So what's the high level conclusion? The high level conclusion is, please do analyze the trade-offs very, very carefully. Now let's make a summary of some important points. The first is that the process of organizing data into columns and tables such as to reduce redundancy in the data is called normalization. Second is that a database transaction is a set of database operations which performs a single logical operation. And finally, a database transaction should follow something known as ACID properties. So atomicity, that is either all operations within a transaction happen or none at all. Now this kind of makes sense. You can't have half the number of transactions happening. Either all the transactions happen or none of the transactions happen. Second is consistency. That is, the state of the database after a transaction should be valid. What does that mean? That really means that no constraints that we have imposed should actually be violated. The third is isolation, and this is an important point, which is that the result of running two transactions concurrently should be the same as if they had been run serially. This is self-explanatory, but essentially what it just says is that if you were to run two transactions more or less at the same time, then it should be the same as if you had run the first one and then the second one after that. And finally, of course, the issue of durability. That is, once a transaction is actually completed, it should persist in any conceivable scenario. So for example, even if the database crashes or there is a power loss, the transaction should persist even if there was a database crash or a power loss. So now let's just highlight some key takeaways for this particular module. Recall that our objective was to give you an introduction to basic data modeling concepts. In that, while modeling data for an SQL database, the first thing to remember is to please make sure that there is only a single source of the truth. Remove any redundancy in the data, i.e. normalize it. The second is that understand and model your constraints well. The third bit is analyze all your trade-offs. So essentially what that means is study established patterns and do not take a decision without actually experimenting yourself. Now this is really, really important. This is very important from a learning perspective. This is extremely important from a design perspective and from an engineering perspective. Okay? And finally, a key takeaway in terms of transactions is that it is rather important for applications where there is a significant amount of data processing, i.e. there are many database requests, and concurrent usage of the database could result in inconsistencies. So this provides now a summary to data modeling and constraints within databases.